Hey, this is Steven from LegitTechTutorials, and welcome back to my product design series. We are back looking at the designing the smart mixed chemistry battery charger. So I have got in I originally filmed that last video on, it was a Wednesday. I didn't actually get it uploaded till, wait no, it would have been, it was a Tuesday. I took the video, did the video on Tuesday, didn't get it uploaded till Thursday. So on Wednesday I bought these, February 14th, and I have them in. I have them now in front of me. Another thing, also, as you saw, I was looking originally at the red one, but I realized that that red one that I showed you from wherever, whatever it was called, from Zyne, it was like 1200 watt. The issue with that one and why I changed to using this, which is a LT something or other. Uses an LT regulator, an LT something IC. Yeah, LTC 3780. Yeah. LT3, what was it? LT3780. So look that up. You find out what it is. I think that's a very common. I'm taking EE98 right now at my university for mechanical engineering. It's like one of the two electronics classes we have to take, and I believe we are working with these specific regulators right now. Of course, we're not worried about any of the resistors and stuff. We're learning how to, how it regulates and blah blah and that. So again, it's this one, the LTC 3780. And I bought the 80 watt, so the 80 watt could do a max of 10 amp peak and a peak of 130 watts. If you do over 80 watts, you're going to want to strengthen your cooling system on these little heat sinks. These in the LTC 3780s are, there's one here, one here, one here, one here. And you're going to need to cool that. So this guy is a automatic, as they say, pressure, automatic lifting pressure, constant voltage, step up and step down. So that means that I could feed it my 14 volts and then be able to regulate it down to 1 volt. As long as I could regulate it down to pretty much anything. So it's not just a step down; it's a step up and step down, automatic changing. So that means that we could. It's automatic boost and buck, right? Module built into one. So that means that we can put in 12 volts and be able to boost the voltage up. And we'll be able to, I'm opening up the bag that it's in, by the way. So be able to boost the voltage up as well as drop the voltage down. So that way we could charge 1 cell and 2 cell. 1 cell being 3.7 for most chemistries, 3.7 nominal, and 2 cell being 7.4 nominal. And also 11.11 nominal. Right? 11.4, 11.2, something like that. 3 cell. So we could drop it down for that guy, and then 14 volt plus for 4 cell, 14.8 I believe, or something like that. And then you have 5 cell, 6 cell, 6 cells 25.2 nominal, some stuff like that. So this guy will be able to do all that, be able to do 1 to however much, until we start to bounce off of the watt rating. Alright, so looking at it right now, yeah, so this is using the linear technologies LTC 3780. I have to look at my homework here in a minute to see if that's what we're actually working on in my homework, but I believe that's what it is. But not really a big issue right now. Board looks very clean. Very few solder joints. Most of it is surface mount. Surface mount is very clean, so that's good. And then we have our other two pieces. So the one thing that I do not have right now is these guys are on the slow boat from China. Okay? They're gonna take a while. The two digital pots are gonna take a while. And does it say on here? It doesn't say on here the resistance needed. And actually, one of them is not really soldered on that great. So luckily, these are going to be taken off. And here on the bottom it says V out set, CC set. So these are again the V out set, the constant voltage and constant current, and also it has the third one on here is the UV, which is under voltage protection against brownouts and stuff. So that guy I'm going to turn all the way back to 10 volt or whatever. Because I'm not gonna have a pot control that one, which one is that one? That is, it would be this one. It would be this one here. So this is the constant voltage, this is the constant current. Alright, so these are on a slow boat from China. These I have that one. This one, yep, there's 25 volt. The current one, yeah, 25 volt. And then I have the other one, which is the GigFun 30 amp range current sensor here as well. This one's in a little bit nicer bag of the other one, but it's also soldered as well, I believe. It's a little anti-static. The other one just came in a little baggy, and the LTC 3780 came also in an anti-static. The soldering on this looks good. Soldering looks good. What about on this one? Oh, it's got a little spot for like an on-off switch, so that's pretty cool. A little spot where we could solder some pins in to do an on-off on this voltage regulator board. This one solder also looks pretty good on the voltage control. Alright, so with that being said, we are ready to go. So I looked online for 123D circuits. It's been a while since I've used it, and unfortunately they do not have the Mega. They do not have the Mega version. So so that's going to be a problem. Because they do not have the Mega, we're going to have to work without it. So you could not simulate it on there. All they have is an Uno and a Nano. They do not have anything as big as a Mega. So the other idea was to use Eagle, which I did download, but I have no clue how to use it. So we're going to be using what I know how to use a little bit, which is Illustrator. So we're going to draw the schematic on the Illustrator here, so later when I learn Eagle, we could transfer it from there to Eagle. And we're going to be going off of the images of those digital pots online, and also what I have here physically to lay out all the wires that we're going to need. Also later on I did find a PDF for the Arduino Mega, so I might just drag and drop that in here and then draw the lines out of each wire to figure out which wire is going to do which, etc, etc. But right now what we're going to do is we're just going to draw these pieces. I'm curious if I really want to do this to size, because I do have my calipers here. Because this is actually in pixels, so I don't know if it'll let me. So this is basically 3 inches. By 1.75. There we go. Okay, that looks okay, I guess. And then now that's the regulator. Now this guy is the voltage sensor. It is 1 inch long, 1 inch long by 1/2 inch wide. Okay, oops. Alright, let's go ahead and put some text on here. This is the LTC3780. Okay, and then this is the voltage sensor. Just gonna put a V on here. There we go. Voltage sensor. And then we got this voltage sensor. Current sensor's a little bit longer. This is 1.2 long or wide. 1.2 by 0.5. Oops. Oh man, added stroke to added a fill. Alrighty. What the hell? There we go. Okay. Another thing is I'll probably change the view because this is way too big. So you'd be closer in. So I'll go into the document setup here in a second. Let's say this is 2 feet, 24 inches. Oops. So yeah, this is, let's see. Say 12 inches. 12 inches. I like doing a lot of layout in here. It's pretty good. Okay, view, fit output in window. Okay. Alright, so there's a few things on this guy. We're going to have these pots be the bottom. So, let's go in here, and then I'll just put this wherever. So this is This guy, it's the center one, that's constant current. Constant current. So, and it takes 3 pins on that. 3 pins. So this one over here in that corner is, so it would be that one. This under voltage UV. This one is CC. This one would be the CV. Alright, so those are those, and then we have the out and in over here towards this corner here somewhere. It's like right here, and then there's the hole. So this, it's a little bit, let's just do it a little bit wider. This guy is the in. And then this guy over here is the out. Alright, we're at 15 minutes. Okay, so then the constant current, oh, not constant current, sorry, the current sensor, which is this one, has 3 pins in one, and in and out and in and out. So current one, and then this one will just be pins. So what I'll do here is I'll do circles. You get the idea. Okay, so that one's the current guy, and then this is the in, and the V is the out. I'll just do some circles inside this one here as well. Using this little TV food table. There we go. Okay, So that's all the stuff I have right now. So let's say here, but we'll do a few pieces of text here. This one is my text might be a little big for this. That's fine. This is the voltage, and then this is V, and then this one's out. Because this is actually slightly different as far as the layout for the other one. Oh. Okay. Okay, so but on the current sensor, it goes ground is the bottom, out is the middle, and V is the top. Okay. And now regroup these, object group. Regroup that one, object group. Alright, so those are those. Then we have these ones. As VCC, RH, RW, RL, ground, VCC, ground, INC, I guess that's increment. Say voltage divider, VD, and then chip select, something like that. I'll figure it out when I get it. But do they have a dimension? And no. Resistance increase mode linear. Okay, that's good. Sorry about that kind of text. Oh, but I closed out my timer. Okay, let's just say for now, let's just say it's like let's just say it's like 0.8 by 0.8. Let's just say that. Which, for me to guess, that should be around the right size. Okay, 0.8 inches, 0.8 inches. Okay. And then now with this guy, what we'll do is we'll set it up where we do all the stuff at once. So this one has, how many sets? 1, 2, 3, 4, 5, 5 by 5. So what we'll do, I'm gonna have to draw them again. That's fine. There we go, and then we call this one the pot. Let's put P. it's a perspective mode. I don't know how to get out of that. Anyways. It's not like we have anything in perspective right now anyways. Where's my right? What did I do? Anyways, I'll figure it out. Get out of perspective mode later, but it should still allow us to do stuff with this. There we go. But it's doing some sort of weird, maybe not. I thought I was doing some sort of weird perspective mode because this top piece is really flat, but I guess not. Alrighty. VCC, RH, RW. RL to ground. Okay. VCC again, VGINC, VG. It's gonna have to be in like 6 point. Oops. INC. Might be a little too close. INC U/D. Oops. Let's just say this is UD. Okay, and then the last one. Yes, chip select. Chip select pin. CS. Alrighty. That looks good. 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 Where are those weights at? Downstairs. That's good, that looks good. Alright. So with that, we have all of our current pieces laid out, except for the hardest one, which is going to be the Mega. Obviously, with the Mega, we're not going to have to do too much crazy stuff with it. We're not going to have to, model all 54 pins or so. We'll just model the ones we need to use, and then keep the other ones not used. So the first 18 are all going to be used by the touchscreen. So we're going to be using all of the pins on the back. Then maybe for that I'll just import a PDF of the piece, because they have some layouts of it. As you see with these, you can't really do a PDF of these because there's no, this one there might be, no. There's no like right over the top images, except for that. That might have worked. And maybe even that. Maybe I'll change that out for that. Anyways, yeah, so everything looks good. Ready to rock and roll and draw some wires, and also have the wire colors in Illustrator coming out of these guys and going into the Mega, so you know which one goes where, which wire goes where, what wire is doing what wires to what pin, and then we'll work on programming it when hopefully by the time the digital potentiometers get here. But I believe it's going to be a while till those get here. So probably what we'll do next week on Friday is lay out the Arduino Mega, connect these together, figure out which pins, maybe do some, maybe find some code for these high let go digital potentiometers, and figure out how to operate them, and then come up with some basic stuff for coding. Yeah, so figure out the wiring colors, figure out which pin it's going to go to, and then start prototyping the code so that when those digital potentiometers get here, we could wire directly up. Also, another thing I would like to test is just to run this guy on just some sort of load on like a heater band or something. Just some random load, like actually a fan would be nice to run it on a fan, and then have like a digital potentiometer off of the outlet here, and then mess with these potentiometers to make sure this guy works, so that if this guy doesn't work, I can return it and get a new one by the time that potentiometer gets in here. And also to figure out what resistance area we're looking at here. Also, I could email them about the range for these potentiometers, the resistance range that is needed, so that I can have that in my code, because as you see with this one, it goes from from 40 to 100K. And I don't know what exactly the steps are on that, so that would be another thing to check out. So have this guy ready so that this linear regulator here, the step up, step down, checked, make sure that these potentiometers work, figure it out, and then make sure that this works so I don't have to return it, and then by that time have the Arduino Mega modeled, these guys desoldered and ready to solder the pins for the digital potentiometer into this guy, and then go from there. Alright, this has been Steven from LegitTechTutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like in this series and other series as well. I'll see you guys next video. Thanks for watching. Take it easy. Peace.